Alright guys, so last video for 3.3, yay, it talks about radiocarbon dating. So I'm just going to kind of read you some stuff here, and then we're going to move right on into our example 6. So carbon-14 is a form of carbon that decays radioactively with a half-life, which is the time required for half of the given mass to decay, of 5,700 years. After the organism dies, the age of its remains can be calculated by determining how much carbon-14 has decayed. And so that's just kind of a prelude here to what we're going to do in example 6. So example 6 has a lot of reading, so I'm going to read through it, and then we'll go back through and pull out what we need. And it's King Tut's treasure. It says in 1960, a group of specialists from the British Museum investigated whether a piece of art containing organic material found in King Tut's tomb had been made during his reign, or whether it belonged to an earlier period. We know that King Tut died in 1346 BC and ruled Egypt for 10 years. What percent of the amount of carbon-14 originally contained in the object should be present in 1960 if the object was made during his reign? And it reminds us here, then on the next slide there, that the half-life of carbon-14 is approximately 5,700 years. Alright, so what we know. Well, we know it's decaying, but we don't know the rate, so we need to find K. So again, we're going to use that exponential growth or decay. So we're just going to use the growth, and then remember if it's decay, our K value will be negative. Alright, so we're looking at A of t is equal to the initial amount times e raised to the kt. Alright, well, we're talking about the half-life, and so we don't know how much we started with. We don't know how much was there at the very beginning, so we're just going to let it be our beginning amount. But if we're doing the half-life, we know that half of the beginning amount is left after t years. So A of t is going to be half of what we started with. So half of the original amount. And then t is going to be the 5,700 years because we're talking about the half-life. Alright, so we plug that into our formula here. And so we've got A of t is 1/2 of the original amount. The original amount is just going to be the original amount. E to the k times, we said t was 5,700. So we're going to solve for k. It's up in that exponent, so let's get that exponential part there by itself. So divide by the original amount. And notice my original amounts cancel, so we're left with 1/2 equals e to the k times 5,700 is just 5,700k. And then once again, we're in exponential form, and we're stuck. So I'm just going to switch the sides here. So it's b to the y equals x. My base is e. My y is the 5,700k. And my x is going to be x. So when I set it up into log form, I have log base b of, x is not x, x is 1/2. Sorry. Log base b of x, which is 1/2, equals y, which is a 5,700k. We know log base c is the natural log. 1/2 equals 5,700k. Divide by 5,700. And so I'm going to go ahead and put this one in my calculator. And so I'll end up with that k is approximately negative 0.001216. And it's a rate, so I went several decimal places out after I finally got through all those zeros. Alright, so what we know right now then is that we have the equation here that A of t is equal to whatever the ending amount, is equal to the initial amount times e raised to the negative 0.001216 t. Alright, so we know this equation. Now, remember the time t that elapsed between King Tut's death in 1960, we could find that by saying that that time is equal to, well, we know it's been 1,960 years AD, plus we said it was at 1346 BC. So we add those together, and it's been 3,306 years. So let's find, they wanted us to find how much would be remaining at the time of his death. So we're going to find now A of the 3306. So the amount left after 3,306 years. So we still don't know the original amount. E to the negative 0.00012116 times the 3306. And so when we work this out, we get that the amount after 3,306 years remaining excuse me, is approximately, we don't know the original amount, but we can go ahead and we can work out this E to the number right there, and we get that that's like 0.66897 times that original amount. So now that means that we know the amount remaining, and I'm going to abbreviate some on this, the percent remaining, because it's a rate. So the percent remaining of the original amount of carbon-14 in the object after 3,306 years is 66.897%. All right, but it also said here, let me go back to the problem. It said, what percent of the amount of carbon-14 originally contained in the object should be present in 1960? If the object was made during his reign. All right, so we found how much would be left if it's from when he died, but now how much if it happened during his reign. So, to find that, we know that his reign was for 10 years. So we're just going to add 10 years to our T. And so I'm going to come over here where I did the work here at first, and I'm going to erase it. Alright, so now, because we're looking at, did it happen like the beginning of his reign or before his reign then, we're going to let T equal the 3,306 plus the 10 years. So we're going to let it be 3,316. So A of T is equal to the initial amount. I'm using the same formula, E to the negative 0.0001216T. And let's plug in that T is 3316. So the amount that should be remaining after 3,316 years is equal to the original amount times E raised to the negative 0.001216 times 3,316. And so just like we did before, we're going to work out the exponential part. And so that number is going to give me 0.66816, and that's going to be times the original amount. So what that's telling us then is a piece of art made during King Tut's reign. So I'm going to write this out. A piece of art made during his reign would have between all right, so we know that this 66.897% is the amount that if it was at the end of his reign when he died. We know this here, now we didn't write it, but remember this as a percent would be 66.816%. That's if it was at the very beginning of his reign. So if it was during his reign, it's got to be in between those two numbers. So a piece of art made during his reign would have between 66.816% and 66.897% of carbon-14 remaining in 1960. So what we did there was we found the percentage, like I said, over here at the end of his reign. So when he died, how much should have been left? We found over here at the very beginning of his reign. And so the question was how much if it was made during his reign. So it has to be in between those two numbers. All right, guys, and that wraps up 3.3. Yay! And so I'm going to get this uploaded I'll get it on YouTube, and I'm going to get it up on your Blackboard or your It's Learning for my high school class. And so hopefully this helps some.